Okay, so when we talk about, when we talk about quadratic function, how many x-intercepts does a quadratic function have? I should say function instead of equation here. Quadratic function. How many x-intercepts are possible? You could have 2. Yeah. Could you have 1 x-intercept? Yeah. Can you have 0? Yes. Can you have 3? No. So it's 0, 1, or 2. Okay? And so the x-intercept occurs when what? When y is equal to 0. So when y is equal to 0, that is where our x-intercept occurs. Right? When y is 0. As a result, by finding the x-intercept, we can solve any quadratic equation. So what I mean by that, a quadratic equation in the form of 0 equals ax squared plus bx plus c, if we can factor that, right? If we're looking for when y, so to speak, is equal to 0, we're looking for the x-intercepts. If I was trying to solve something like that. So when y is 0 is the x-intercept. That's going to be the solution to a quadratic equation. So our goal is always to put it in this form. We always want it 0 equals, and then our quadratic, because then we're looking for the y-intercept, or the x-intercept, when y is 0. So there's some terminology. I kind of mentioned them before. This is really important. The terms roots and zeros. Roots and zeros and x-intercepts are all the same thing. When I'm asking for the roots, I'm asking for the solutions to an equation. When I'm asking for the zeros, I'm asking for the solution or the x-intercept. These are all the same thing. Roots, zeros, x-intercepts. They all mean the same thing ultimately. Okay? So you're often going to hear the term zeros or find the roots. You need to know that means x-intercepts. Okay, just simple terminology. Okay, so how do we do this on our graphing calculator? So let's grab our graphing calculator. If I wanted to solve this. Now notice, is this an equation or a function? X squared plus 4x plus 3 equals 0. Well, I guess functions are still equations, but this one, in terms of this unit, is called, it's a quadratic equation, right? There's no y variable. We're not comparing y with x. So it's definitely not a function. There's only one variable. So this is a quadratic equation. All right, grab your graphing calculators. Okay. It's clear what's there. You have to reset your windows, zoom 6. The windows here are -5 to 5. So let's do that, the same thing, okay? So let's go to our windows and make it -5 to 5, scale of 1. -5 to 5, scale of 1. Okay, just because that's what the graph that's given is. So let's do the same as what's given. Okay, so if I want to get some nice points, where do I go to get some nice points? Where can I go if I want to graph this as a test? I just want to do it quickly. Second graph will take me to my table, right? And so we can plot some points there. X is -3, y is 0. -2 is -1. -1 is 0. 0, 3, that's the y-intercept. Very simple, right? Okay. So the roots or the solution, it says solve. The solution, when it says to solve, is what values of x would make y 0? Or what are my x-intercepts here? What are the x-intercepts? -1 and -3. Okay, that would be our solution to this equation. And you can check that by just plugging those numbers in. Does -1 squared plus 4 times -1 plus 3, does that equal 0? Well, let's check. plug that in. Negative 1 squared plus 4 times negative 1 plus 3. Does that equal 0? Yep. So that's one of the solutions. That would make that equation 0. Negative 3. When I square it, plus 4 times negative 3 plus 3, does that equal 0? Yeah, 9 minus 12 plus 3. 12 minus 12 is 0. So the solutions to any, when we're solving this, we want one side equals to 0 so we can find our x-intercepts. When it says to solve, what we're looking for are the x-intercepts. How do I find the x-intercepts on my calculator? The 0. So second trace number 2 will give you zeros. Okay. Second trace number 2. Okay, let's try this guy. X squared minus 4x plus 4. So y-intercept this time will be 4. Okay, so y-intercept's 4. Where does it look like it's the x-intercept is? What would be the solution to this guy? X equals 2, because that's the x-intercept. So if I were to plot this, you go to your table of values, or you know the a value is 1 in this graph, right? And so 1 over 1 up, 2 over 4 up, that's the relationship, right? Do you remember doing that? We also know that in this case, this is the axis of symmetry. So if I know that the y-intercept is 4, then I just found 4 opposite, right, on the axis of symmetry. So the solution would be x equals 2. If I wanted to check, is 2 squared minus 4 times 2 plus 4 equal to 0? Oops. Well, is 4 minus 8 plus 4 equal to 0? Yes. Okay, so that's our solution. Only one solution. So just like a function can have 2 x-intercepts, 1 x-intercept, or 0 x-intercepts, our solutions, we can either have 2 solutions, 1 solution, or no solution. So what do you think is going to happen in this next one? No solution. 0 or no? None, yeah. Probably. So let's graph that guy quickly. X squared minus 2x plus 2. So now our y-intercept is positive 2. Right, because our C value, do you remember that? It's going to be on your test tomorrow. Your C value is the y-intercept. Vertex is at 1, 1. 2, 1. Sorry, 2, 2 is another point. And then right at 5. So you can double check your coordinates if you want. So here this has no solution. Because we have no x-intercepts, there is no solution. Okay, so all we're doing is if I'm asking you to solve something graphically, what do you have to do? So if I had to, let's just add a little example at the bottom. If I ask you to solve 3x squared plus 5x minus equals 7 graphically. I really hope this works out. I think it will. Yeah, it will. We're good. Okay, if I ask you to solve that graphically, ultimately we want to be looking for the x-intercept. So the first thing we want to do is get one side equal to 0. Okay? So get, and that's always going to be our first step. Get one side equal to 0. So how do I do that? Subtract 7. So our equation is going to become 3x squared plus 5x minus 7 equals 0. Okay, now what will I do? Graph it. So let's graph it. Clear. I might have to change my windows. I will have to change my windows, actually. I'll just go back to standard windows. So y equals 3x squared plus 5x minus 7. And how do I reset my windows? Same 6. Okay. So I graphed it. Now what do I want to do? Find my x-intercepts. How do I find my x-intercepts? I can't spell. Try this again. Intercept, so second trace 2 for zeros. So second trace 2, we'll have to do this twice. How do we do that? Is that me or somebody else? Oops, is you? Okay. Just turn it off, it's all good. Enter, right side, enter, right, left, right. And your guess, you don't really have to make a guess. So the first one would be negative 2 point. Let's go to one decimal place. Negative 2 point. What do you get? What is that? Can you see it? 6. Okay.
Here we have all grade 11 students with the last names beginning with the letter M.
There you go.
Please come to the library to choose your course for next year. That's grade 11 students with the last name beginning with M. Please come to the library to choose your course.
Do you need this? Let's turn it off. Notice how it says for y, 1e negative 12. Does yours give you something like that, or did it say 0? Yours said 0? 1e negative 12 is essentially 0, right? Scientific notation, 1 times 10 to the negative 12. That's what that means. That would be moving our decimal place at 12 to the left. Is that essentially 0? Yeah, like your calculator's doing a calculation. It's not going to be perfect. That's essentially 0, Chase. No, I know, but it's essentially. Okay. There's always 1. Just funny. It is essentially, I never said it is 0. It's essentially really close to 0. Is that better? Okay. All right, and again, so this guy, oh, that one's better. Y equals 0. 0.9. So those would be your solutions to the nearest 10th. That's it. Okay, that's solving graphically. Easy? Yeah? Lesson 1 done. And that's why we're starting the next part. Pretty simple. So that's solving graphically. Get one side equal to 0, plug it in your calculator, find the x-intercepts. That's all you have to do. That's the solution. Yay! You just study for tomorrow. We're just going to do a little bit of factoring review. I'll leave the rest for when we get back. Just a little bit. Not all of it, just a little bit. Do you need to study? Oh. Okay, well, let's just do just a little bit. I'll make sure to leave lots of time, like 10 minutes worth. Okay? And then you can have the rest of class for studying. Sound good? Okay. So I'll do the rest of these on Monday after spring break. We'll just do a couple. Do you remember how to GCF? Greatest common factor. Yes. GCF. Okay. 36, 42, and 18. What's the largest number that will divide into 36, 42, and 18? 6. Good job. So 6. Okay, we can divide each of those by 6. What else? When you're pulling out a common factor for variables, if I have an x to the 6th, I'll zoom in, and x cubed and x to the 5th, what can I divide all of those by? X to the what? We have a power of 6, power of 3, and power of 5. The only one that you could actually pull out that's in common with all three is how many x's? No, more than one. It's going to be the smallest power that's there, x to the 3. So the smallest power is x cubed. We can divide each one of these by x cubed, right? And when you divide, what do we do with the exponents? We subtract them. We're going to subtract them. Okay? Y to the 7, y to the 4, y to the 5. What's the highest power that we could pull out? That's in common. That's in common with all of them. Y to the 4. It's going to be the smallest exponent. So y to the 4. We can divide them all by y to the 4. And so that's our GCF. Our GCF is 6x cubed y to the 4. And when we factor it out, we have to figure out what's left over. So what's left over here? 36 divided by 6. 6. X to the 6 divided by x cubed. How many x's left over? If we pulled 3 of them out, there's 3 left over, x cubed. If we pull 4 out, how many y's left over? 3. Minus 42 divided by 6. 7. X cubed divided by x cubed. That's gone, right? It's 0. It's actually 1. It reduces to 1. We don't have to write it. We've already pulled all of those x's out. Y to the 4 divided by y to the 4. Pulled it all out. Reduces to 1. Gone. Okay, plus 18 divided by 6. 3. X to the 2. So 5 minus 3 is 2. We take 3 x's out of x to the 5th. We have 2 x's left over. And last, y to the 5th divided by y to the 4 is y. Coming back to you. Okay, let's look at 3. What is my GCF here? So think of it as this as one term, and this guy is one term. What do they have in common? Not just 3. X plus 3. They have the binomial of x plus 3. So x plus 3 is actually my GCF. That's what we're going to factor out. We're going to factor out x plus 3. And so if I divide each of these by x plus 3, what's left over? 5 plus, it's gone, this is gone, 5 plus z. That's it. So that's a binomial GCF. They both had x plus 3 in common. There's a binomial GCF there that we factored out. Okay, good? Okay, really quickly, do you remember how to factor trinomials? Chinese method we used, right? No? Did anyone learn decomposition? No, you were in my class. I know how you were taught. Okay, so I don't know how your teacher wrote it. So it might be a little bit different depending on how but it's essentially the same process. So when we're factoring this trinomial, what we want to do is figure out two numbers that multiply to the coefficient of the x squared. So the coefficient is a 1. Only way to multiply to 1 is what? Only two numbers that multiply to 1. 1 times 1. Okay. Same idea. We want to figure out two numbers that multiply to 12. But here's the catch. The catch is that these diagonals, when multiplied together, when we sum them, they have to add to the middle term. Add to 7. Okay? So a simple trinomial is easy because your two numbers you're multiplying to will also add to the middle term. So what two numbers multiply to 12 but add to 7? 4 and 3. Okay, do you see how 1 times 3, so this diagonal right here, 1 times 3 is 3. 1 times 4 is 4. 3 plus 4, 7. Okay, and so what happens is each row becomes a factor. This is one factor, one factor. Hello.